Hey everyone, so we are back to continue our Factoring 101 series, and as a quick recap, in our previous episode we learned how to factor trinomials, and I had mentioned that we were going to split it up into two parts, and in the first part we learned how to factor trinomials where the leading coefficient a was equal to 1, and in this video we're going to be going over the second part and learn how to factor trinomials where the leading coefficient a is not equal to 1. So if you struggle with factoring these types of trinomials, keep watching. Alright guys, so like previous episode, we are still focusing on trinomials in the form of ax squared plus bx plus c. But this time we're focusing on the leading coefficient a not being equal to 1. Okay, we're going to learn how to factor that. So when we initially factor the trinomials in this form, where a is not equal to 1, we want to factor it to become ax plus p times ax plus q. The a, when we factor this, represents the leading coefficient a. And to identify what the values of p and q are, it's going to be very similar to our previous episode. However, this time we're going to be focusing on our leading coefficient a and our last term c and our middle coefficient b. So we want to make sure that when we find the values of both p and q, we want to make sure that they both will give us the product of the leading coefficient a times the last term c, and we want to make sure that it'll give us the sum of the middle coefficient b. Now, notice how I said initially, okay? Because there's going to be another step that we're going to have to take after we initially factor it. But let's make sense of this all and jump to our first example. Alright guys, so in our first example, we are given the expression 5x squared minus 37x minus 24. So if you saw my previous episode, you know I use this method called the x factoring method. It's not necessary, but it is helpful. So what we're going to do is create an x, and essentially we want to fill up all the sides of the x. So in order to do this, let's start with filling up the top of the x. Now in order to find the value that goes in the top of the x, notice how our leading coefficient is 5, okay? So what we're going to do is take our leading coefficient 5 and multiply it to our last term, negative 24. And when we do that, that'll give us negative 120. Once we do that, we're going to put their product, negative 120, at the top of the x. At the bottom of the x, we're going to put our middle coefficient, negative 37. And now what we're going to do is try to fill up the sides of the x. And in order to do this, this is when we have to find two values that will both multiply to give us the top of the x and add to give us the bottom of the x. So let's just focus on the top of the x and figure out some pairs that we know will give us negative 120. So I'm going to list a couple or several pairs. So a pair that I can think of is negative 4 times 30. We can do 4 times negative 30, 10 times negative 12, negative 10 times 12, 3 times negative 40, and negative 3 times 40. Now that we've identified all our pairs, let's figure out which one is going to also add to give us our bottom value, negative 37. So if we do negative 4 plus 30, we know that's going to give us positive 26. So that doesn't quite cut it, so we're going to eliminate that. We'll do our next pair, and we'll do 4 plus negative 30. That's going to give us negative 26, so we'll also eliminate that. 10 plus negative 12 is negative 2, so that's cut out. Negative 10 plus 12 will give us positive 2, so once again, we're eliminating that. And then we'll do 3 plus a negative 40, and that will give us negative 37. So we'll put a check by that because that works. And then lastly, we have negative 3 plus 40, and that'll give us positive 37. So we'll eliminate that as well. So the numbers that we're going to put in our sides of the x is going to be 3 and negative 40. Remember, order doesn't matter, so if you did negative 40 and 3, that's perfectly fine. So now what we're going to do is factor this. So remember, when we initially factor it, it's going to be in the form of ax plus p times ax plus q. So remember, our leading coefficient, a, is 5. So we'll factor this to become 5x. And then one of our sides is 3, so we'll plug in 3 into our p, so that'll be plus 3. And it'll become times 5x plus, and our q would be a negative 40. We'll clean this up and it'll become 5x plus 3 times 5x minus 40. Now, remember I said there's going to be another step that we have to take. And what we're going to have to do is factor this a little more. So notice our two groupings, and notice that we can actually factor one of these groupings. Our 5x plus 3, we really can't factor that, so we'll leave that alone. But notice our 5x minus 40, we can actually take out a 5 from that, and that will leave us with x minus 8. So once we factor out that 5, we can actually completely disregard that and cancel it out. And we'll just leave what's left in the groupings, which would be 5x plus 3 times x minus 8, and that's the answer. So remember that extra step, you always factor it completely. Sometimes it'll just be one grouping, sometimes it'll be both, but you'll still have to factor one or both. So let's move on to our next example. Alright guys, so for our second example, we're given the expression 8a squared minus 2a minus 3. So first we're going to create our x, and at the top of the x, remember we're going to take our leading coefficient 8 and multiply it to the last term, negative 3, and that will give us a product of negative 24. And we're going to put that negative 24 at the top of our x. At the bottom of our x, we're going to put our middle coefficient, negative 2. And now we're going to find two numbers that both multiply to our top of the x and add to our bottom, and put those in the sides of the x. So before we find those numbers, let's just focus on our top value, negative 24, and figure out some pairs that we know will give us negative 24. So some pairs I can think of is negative 4 times 6. We can do 4 times negative 6, 8 times negative 3, and negative 8 times 3. So now that we've figured out the pairs, let's see which one is going to both multiply, give us our top value, and add to give us our bottom value, which is negative 2. So if we do negative 4 plus 6, that'll give us positive 2, so we'll eliminate that. If we do 4 plus negative 6, that'll give us a negative 2, so that works, we'll put a check by that. If we do 8 plus a negative 3, that'll give us positive 5, so we'll eliminate that. And lastly, if we do negative 8 plus 3, that'll give us a negative 5, so again, we'll eliminate that. So the pair that'll work would be 4 and negative 6, so we'll put those in the sides of the x. And now we'll factor. So remember, we're going to factor this in the form of ax plus q times ax, ax plus p times ax plus q. So in our a, we're going to sub in the a with our leading coefficient 8. So it'll become 8. I know we say ax, but this time we're dealing with a's, so we'll do 8a, and then we'll sub in the 4 into the p, so it'll be 8a plus 4 times 8a, and we'll sub in the negative 6 in the q, so 8a minus 6. From here, we're going to factor furthermore, and we can actually factor both groupings. So from the 8a, this is a tongue twister, 8a plus 4, we can actually take out a 4, it'll leave us with 2a plus 1. And from the 8a minus 6, we can actually factor out a 2, and it'll leave us with 4a minus 3. Once we factor out that 4 and 2, we can cancel it out, disregard it, and just leave it with what's left, which would be 2a plus 1 times 4a minus 3. Or you can do 4a minus 3 times 2a plus 1. Doesn't matter, order doesn't matter. And that is the answer. So let's now move on to our final example. Alright y'all, so for the final example, we are given the expression 20y squared plus 21y minus 5. So we're going to create our x, and what we're going to do is take our leading coefficient 20 and multiply it to our last term, negative 5. And that will give us negative 100. And what we're going to do is place it at the top of the x. What we're going to do now is put our middle coefficient, which is 21, and place it at the bottom of the x. And now we're going to fill the sides of the x. So in order to fill the sides, remember we're finding two numbers that both multiply to the top of the x and add to the bottom of the x. But let's focus on our top value first, which is negative 100, and figure out, okay, what are some pairs that will give us negative 100? So I'm going to list a few over here. So I know we can do negative 50 times 2. We can also do 50 times negative 2. We can do 5 times negative 20. We can do negative 5 times 20. We can do 5 times negative 4. And we can do 4 times negative 25. So now that we have a few pairs listed out, let's figure out which one is also going to add to our bottom value, 21. So if we do negative 50 plus 2, that will give us negative 48, so we can eliminate that because that doesn't work. We can do 50 plus negative 2, and that will give us positive 48, so once again, eliminated. If If we do 5 plus negative 20, that'll give us negative 15, so we're going to eliminate that. If we do negative 5 plus 20, that'll give us positive 15, but we can eliminate that as well. If we do if we do 25 plus a negative 4, that'll give us a positive 21, which works, so we'll check that off. And if we do 4 plus a negative 25, that'll give us negative 21, so we'll eliminate that. So the pair that works is going to be 25 and negative 4, so we'll place that in the sides of the x. So now we're going to factor. So when we factor, remember it's in the form of ax plus p times ax plus q. Once again, we're dealing with y's this time, so we're going to sub in the x's with y's. So we're going to factor this to become 20y plus, and we'll sub in the p with 25 times 20y plus a negative 4, because we're going to sub in the negative 4 with q. And then once we do this, we can factor furthermore. Once again, we are going to factor both of these groupings because they're both factorable. So we can take out a 5 from the 20y plus 25, and that'll leave us with 4y plus 5. And we'll factor out a 4 from the 20y minus 4, and that'll leave us with 5y minus 1. Once we do that, we can cancel out what we factor. We can cancel out the 5 and 4, and it'll leave us with 4y plus 5 times 5y minus 1. Or you can do 5y minus 1 times 4y plus 5. Remember, order does not matter. So that pretty much wraps up this episode, guys. Stay tuned for our next episode because we're going to be learning how to factor perfect square trinomials. But in the meantime, take care.